So next we're going to hear about sample bias related to household role from Marcin Hitczenko. That's close. Marcin is a statistician at the Federal Reserve Bank of Atlanta after holding a similar position at the Federal Reserve Bank of Boston since 2012. He currently works on various business and consumer surveys housed within the Economic Survey Research Center, most notably the Diary of Consumer Payment Choice. In addition, his research interests broadly relate to improving inference based on survey data. Marcin has a BA in applied mathematics and a PhD from the University of Chicago.
Okay, thank you very much. So I'll get right to it. This work, I think, addresses a small slice of a broad issue in survey statistics, which is sort of the alignment of the sample with the population. So here's a brief outline. The setting of this research is address-based sampling, and specifically selecting people from within households. The data we'll be using is the 2019 Survey of Consumer Payment Choice, which I'll introduce in a little bit. And we're going to ask basically two questions. One, is the set of household representatives that make up our sample skewed with respect to financial responsibility? And if so, does it matter? Does it affect various inferences that we want to use with our survey? So I don't think I need to say too much about address-based sampling, except in the context of the general population, it effectively reduces to sampling of households. And a key focus here is on how that occurs. So generally speaking, one member of the household is selected, one individual, which I'll refer to as the primary contact, to either join the panel or take the survey. And this can be done in a variety of ways. It can be done in a sort of less conscriptive way, which is sort of you outreach to the general household and see who responds. You get whoever comes forward. Or you can add a probabilistic element to it by, for example, asking for the person with the next birthday or maybe the last birthday. Of course, nothing guarantees great sample representation. Okay, so as I mentioned, we're working with the Survey of Consumer Payment Choice, or I'll refer to that as the SCPC, which is an annual survey in the Federal Reserve System that focuses on payment adoption and use of U.S. consumers. The 2019 SCPC had about 3,000 respondents, and they came from the UAS panel, which I think everyone's familiar with, which does use address-based sampling and as multi-stage mail recruitment. The key feature I want to highlight about the UAS panel that lets this work happen is that additional household members are invited to join the panel. So in fact, for our SCPC survey, which had about a little under 2,700 households, 13% of them had multiple members in the sample and 10% were fully sampled, meaning all adults participated and took the survey. So here's the financial responsibility questions. So each respondent is basically asked to assess their level of contribution for 4 activities on a 5-point ordinal scale, going from none or almost none, which we code as 0, to all or almost all, which we code as 4. And the 4 activities, it's hard to read maybe, are paying monthly bills, household shopping, decisions about savings and investments, and then other financial decisions. So here's the distribution of those responses. The focus, there's some differences, of course, but the focus here is the skew towards higher values, so greater levels of responsibility. Now, what we don't know is to what extent this is a manifestation of a selection bias, and to what extent it's tendency of people to overstate their contribution, which is a well-known, well-documented phenomenon. So that's where the multi-sample households are going to come in and help us get at this. So first, we're going to trade in a little bit of granularity of information for simplicity and just combine the scores to make one measure, F, which is just going to be the sum of the numerical ratings. So now it goes from 0 to 16. Again, higher values of F correspond to more responsibility. So in theory, within each household, the sum should be 16 if the household is internally consistent. And of course, there's good reasons why that won't always be the case. But here's a plot, a scatter plot of scores in multi-sampled households. So on the x-axis, you have the primary contact, and on the y-axis, you have the sum of all other household members. Most of the households are 2 adult households, which is on the left. And you can see that there is a negative correlation, which is good. But quite a few, most of the points fall above the dotted line. So indeed, there's clear overstatement of contribution. There must be. The sums are too high. So this is where the statistical model comes in. So I'm going to gloss over a lot here, but basically we define lambda as the true share of household responsibility as defined by our 4 activities. And as a share, the sum within each household of lambda must be 1. And basically we fit a model that links F to lambda. Essentially, I think that we're trying to minimize the distance between lambda and the implied lambda from F, subject to this constraint, the sum constraint. So on the right here is an example of what the model sort of shows for example, for lambda is equal to 0.2. So you can see that for all households, the most common response is F with 3, but there's considerable error, especially towards higher values, so overstatement, and in particular for larger households. And then, so this model, basically what it gives us is values of lambda, distributions of lambda in the population and also in our sample. So here's an example of what that looks like for 5 different households. So X here represents the response-based estimate. So their response F divided by 16. The cluster represents the model-based sort of posterior distribution, and O is the posterior mean, the model-based guess for lambda. So you can see that for example, the 2 leftmost households are fully sampled, and there's a fair amount of internal consistency. In other words, the household scores are either sum to 16 or close. And there, the posterior mean and the response-based mean are similar. X and O are close to each other. The middle household represents another fully sampled household with less internal consistency. Both household members claim to have a majority of the responsibility, which obviously cannot be the case. And you can see there's a lot more uncertainty in what the true lambda distributions for that household are. And the posterior means are shrunken towards the center, towards even sharing. And the 2 on the right show singly sampled households. And again, you can see that there's a shrinkage away from the high extreme. Okay, so now what we can do with this information is sort of compare what we think the average or the mean lambda in our sample is, so among the primary contacts, say, with what the average lambda would look like for a sample of similar size, but now a hypothetical sample where the individuals within households are drawn at random, so there's basically no bias. So we do that for each of these 3 most prevalent household sizes. So the hypothetical distributions, as you would expect, are centered around 1 over the number of members. And those are shown in black. And the And the gray ones are the observed, and you can see that those are statistically above, to the right of the hypothetical. So the conclusion is that even when we adjust for overstatement, tendencies to overstate, the sample seems to have values of lambda responsibility rates that are too high on average. Now, the question is, does this matter? So you can imagine that with each individual, there's some observable measure of interest, y, and we're interested in calculating the mean mu. It's pretty well known that the estimate may be biased if the sample is not representative. So this particular sample bias will be ignorable if one of two things happen. So one is that basically the lambda is can be linked to a known demographic, a demographic with, say, known distributions in the population. So a great example might be something like this, that females are more likely to have a higher lambda, greater shares of responsibility, and are more likely to join the sample, join the panel, complete the survey. And in that case, some sort of post-stratification adjustments should eliminate or fix the bias. A point of note here is that the demographic, to do that, the demographic must be good at distinguishing from within households. So gender is a pretty good one, a pretty good example. But a lot of the standard demographics that are used in post-stratification, like education, age, obviously household income, are not, because they tend to be similar in a lot of households. So it doesn't serve as a good way of distinguishing one person from the next. Okay, so back to the data. One of the things we're interested in is measuring the typical number of monthly payments by instrument type, which is something that's reported by each respondent in the survey. And we consider here check, cash, electronic payments, and card payments. Electronic payments are like bank transfers, not like Venmo or something like that. And card is credit and debit. And again, so for our first estimate is going to be just based on our observed sample, our primary contacts. We'll post-stratify using household size, gender, variety of other factors to get an estimate mu hat 1. And mu hat 2 will do the same thing, but on a bootstrapped sample. And the essential idea again is that we're going to bootstrap the sample by selecting lambdas in such a way that the sample distribution of lambdas sort of matches what we would expect if the intra-household sampling were fair. So we're kind of sort of unskewing the lambdas. So we can do that. There's a lot of ways we can do that. But when we select the lambdas, of course, those are associated with individuals and values of y, which is in this case the number of monthly payments. And then we can post-stratify and generate a new estimate, mu2. And we're interested in the difference, which percent difference here, phi, which is just going to be the percent difference. And those are shown on the right. The distribution comes from because we bootstrapped lots of different samples. And you can see that there's a big difference in electronic payments and check payments, less so for card payments and pretty much none for cash. And this was consistent no matter the methodology we used for both bootstrapping and for generating the estimates. But I think a potential explanation is that checks and electronic payments are used for household bills, household payments. And so they tend to be made by people who have more financial responsibility, whereas cash and credit less so. And so it turns out here, even when we do demographic-based post-stratification, it seems like our sample bias does have an effect and does skew. We tend to overestimate certain types of the frequency of certain types of payments. So that's what I have. So the conclusion again is address-based sampling, I think, seems to yield samples with greater levels of household responsibility, and that this does seep into inference, in this case, on the use of frequency of payment instrument use. I think some questions to think about is how prevalent is this sample bias? Are there other types of similar sort of intra-household biases that come about in sort of in address-based sampling? And then, of course, if so, how can we eliminate such biases? Can we do something which changes the way we make selections, or are there maybe modeling approaches? So yeah, that's it.